We're moving on to 2.2. We're going to talk about infinite limits and limits at infinity, and these are two separate ideas. Okay. Infinite limits and limits at infinity. Now we're really going to get infinity mixed into this. I'm going to start kind of similar to the last section. I'm just going to give you a picture because these things really are pretty intuitive at first anyway. This graph, we've got a vertical asymptote there at 4 and kind of a familiar shape on the left side. It curves up, going up that vertical asymptote. There's also a horizontal asymptote there at the x-axis, so it's curving back down, leveling off, and then kind of flips and does the opposite thing. That's supposed to be nice and smooth. Okay. So the question is, what is the limit of this function f of x as x approaches 4? And well, that's a two-sided limit, right? So if you remember from the last section, we need to look at the left and right sides, and they need to be going to the same place. But, well, the left side here is definitely not going to the same place as the right side, around 4. So this is D and E, does not exist. What if, though, we were to look at the one-sided limits? The limit of f of x as x approaches 4 from the left, the little negative sign. If we approach from the left, well, we're talking about the left side of 4. Where is that going? Where is that function headed as x approaches 4 as we're moving up this way? You think, well, it's an asymptote, so it's just going to go up and up and up. This is going to equal infinity, positive infinity. And kind of in the same way, what if we were to take the limit of f of x as x approaches 4 from the right? You think, well, from the right, it's going down, 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 and that is negative infinity. Okay, so we call these infinite limits because the answer is infinity. Now, the name really is important. It's the concept that matters. But these are the infinite limits. Okay, let's do something a little bit harder. It's always more difficult when you don't have the graph, right? Definitely. Okay. Determine the infinite limit, and now we're given a function and no graph. All right. We've got the limit of 1 over x minus 3 as x approaches 3 from the right. Well, how are we going to go about this? I mean, we don't have a graph to look at. Well, one thing we can realize, if we tried to plug in 3, wouldn't we get 1 over 0 if we attempted to plug in? So obviously that's not going to give us an answer. What does that indicate to us? It's not 0 over 0, right? 0 over 0 would be a whole. It's a number over 0. So we know there is a vertical asymptote at x equals 3 in this case. If there's a vertical asymptote, well then, right, just like in our drawing back here, if there's a vertical asymptote, there's only two possibilities for the answer. It's either going up or it's going down. So we got to figure out, is the answer to this question infinity or is it negative infinity? There's only two possibilities. And we're talking about the right side of 3. Okay, here's how we're going to do it. We're going to create, oh, I kind of explained that. There it is in words. Okay, great. Plugging in gives 1 over 0, so there's a vertical asymptote there. But does the graph go up to positive infinity or negative infinity on the right side? Okay, so it looks like we're going to have to go to another piece of paper. The way we're going to go about this is to use a table. So let me explain how that works. we're going to make a table here. So think of two columns, x on one side and our function 1 over x minus 3 on the other. And we're going to plug in a few values of x bigger than 3. Why are we picking a few values bigger than 3 and not less than 3? Well, because we're approaching from the right side, and so we need values a little bit bigger. X approaches 3 from the right, so use x values, I'll say slightly bigger than 3, and approaching x equals 3. Use x values slightly bigger than 3 and approaching. So what does that mean? So a good place to start, good rule of thumb, is 3.1, a little bit bigger, but then approach 3. So that means they're getting smaller each time, closer and closer. So a good way to do that, 3.1, 3.01, 3.001. And that's kind of depicting this motion, approaching 3. And what we're going to do is plug each one of those into our function and just look at the results and see what happens. And I think we can feel pretty confident about our answer if we do that. So if I plug 3.1 in to the function, I get 10. Maybe verify that. If you plug in 3.01, it will be 100. And if you plug in 3.001, it will be 1,000. Well, what seems to be happening as we get closer and closer to 3? What are the y values doing? And really, there's only the two possibilities. Is it going to positive infinity, or is it going to negative infinity? Well, of course, the answer here, these are getting bigger. That's going to positive infinity. So the value is slightly bigger than 3, approaching 3. And we can tell, yep, these are getting larger and larger. So to answer the question, I'll put it out here. The limit of 1 over x minus 3 as x approaches 3 from the right is equal to infinity, positive infinity. Had these been negative, negative 10, negative 100, negative 1,000, well, we'd say negative infinity there, right? Okay. So we don't need the graph. After all, we can plug in a few numbers and be able to see right away what's going on. And we can correctly identify it as a vertical asymptote. Okay, moving along. Let's look at a harder variety and get rid of this. Ooh, wow, okay, this is a good one. The limit of 4x squared plus 2x over 2x squared minus 9x minus 5 as x approaches 5 from the left. Okay, wow. So now a good idea and not a bad way to start any limit question is just to attempt to plug the number in. Let's go there. Let's just try to plug this number in. If we do, what happens? So I'm going to just grab my calculator here. Let's see here. 4 times 5 squared plus 2 times 5 would give us 110. And then the denominator, 2 times 5 squared minus 9 times 5 minus 5 gives us 0. Okay, 110 over 0. I've got a number over 0. So I know there's a vertical asymptote at x equals 5. But now, you know, what's going to happen here? And certainly, you know, we're going to end up using a table. But it turns out this function, it looks really much more difficult because we can actually factor it and simplify this down a little bit. And so, you may notice, if I copy this part, the numerator we can factor out a 2x, leaving behind 2x plus 1. The denominator factors pretty nicely, 2x plus 1 and x minus 5. And it might take you a moment to do that factoring, but that's how it would play out. And so then we could cancel those 2x plus 1s and get the limit as x approaches 5 from the left, 2x over x minus 5. And now we can really see, yep, if we tried to plug in 5 here, we'd get 10 over 0. And so we'd end up at the same conclusion, that there's a vertical asymptote. But now it's much nicer to work with this version when we make our table. Okay, we could make our table with the original, but that's just a lot of unnecessary work if we notice that it factors. Okay, now this is good. We're approaching 5 from the left. So what does that mean for our table? It means we need to pick values a little bit smaller than 5, but still approaching 5. So a good rule of thumb is to begin, kind of use that 0.1. So a little bit less than 5, let's go with 4.9, 4.99, and 4.999. We'll plug each of those in and we'll see like what it looks like kind of in motion. Some people at this point in the class, they ask, after seeing the last example do we really need to plug in all 3? Can I just plug in one of these and tell from that if it's positive or negative? No, don't do that. We need to see the, I like the word, the motion of the function. We don't just want to get one snapshot of it at one value because we have no idea what's going on around. But if we can clearly see the numbers getting bigger or getting smaller, then it's obvious that it's headed in a certain direction. If you only have one number, you have no idea which direction it's moving, and although it might begin negative, it might actually be moving in the positive direction, or vice versa. So 3 is a good number just to make sure that you did your due diligence. Okay, so with that, let's plug in 4.9. So let's see here. 2 times 4.9, I've got my calculator going on, and 4.9 minus 5, that gives me negative 98. Okay. Well, with just one number, we don't know yet. Let's plug in 4.99. 2 times 4.99 divided by 4.99 minus 5. All right, now I think we got something good going. Negative 998. Let's do one more just to be absolutely sure it doesn't end up turning back around, and you'll get negative 9,998 with 4.999. All right, and with that, we can say with very little doubt that that limit question, that's going to negative infinity. Using the table. Okay, awesome. Okay, you know what? Let's stop this video here. We'll pick it up with limits at infinity next.